Well, hello again. It looks like I'll be giving your Hydrostat Schematic tours as well. If you don't remember me, my name is Dozer Dan. Let's get started by talking about the charge pump. The charge pump is the heart of the hydrostatic system. It is 25.1 cc's displacement and is a gear pump located in the rear drive pump on the pump stack for the left track drive. The front drive pump does not have a charge pump, but it does have a section for it. Flow leaves the FE port because of the blocked off passage and is sent to the hydrostatic filter. Let's go to the filter. Charge oil is forced to be filtered first before being sent anywhere else in the hydrostatic system. The filter head incorporates a bypass. The pressure switch is for warning of bypass on the AIC. The filter head shown in the schematic is the older style of filter head. The newer style filter head allows the oil, after it's been pushed over the filter bypass, to continue on in the hydrostat system. Flow leaves the filter and returns to the hydrostatic pumps. Let's go back down to the pumps. As you see, the charge oil is supplied to the pumps for charge pressure reliefs, items 32, high pressure reliefs, and check valve, item 34. The high pressure reliefs are set to 6,525 psi, and the check valve allows for charge oil to be used as makeup oil in the loop. For example, if oil is lost by pushing over relief, oil has to be added back into the system. We'll also see later on that oil leaves the loop at another location. The servo piston is used to bring the pumps on stroke and off stroke. To get the servo piston to move, the pulse width modulated solenoids must receive a signal from the UCM and shift in order to apply oil to each side of the piston. You'll notice on each side of the piston there are orifices. Note, if you have a momentary mistracking problem, you'll want to go to this area and inspect the orifices for debris or contamination. Momentary mistracking is defined as a brief period of mistracking after commanding forward or reverse travel. Oil is sent out the G-port of the front pump to another component, which we'll see here in a minute. The pump swash plate is spring-loaded to the neutral position. As a reminder, the UCM is needed to give a drive command to the pulse width modulated solenoids. Charge pressure is applied to the servo piston to generate loop flow. The direction of the swash plate stroke determines the travel direction of the machine. Loop pressure then rises from charge pressure to drive pressure. When the machine is in neutral, loop pressure should equal charge pressure. Let's figure out where the oil flows out the G-port to. Follow me. Oh, that's right. It flows to the multifunction valve, which is located under the removable floor plate in the cab. The multifunction valve is used to pour oil to the cooler, parking brakes, and the drive motors. You'll notice item 13, the cooler bypass, is inside the multifunction valve. The parking brake solenoid is mounted to the bottom of the multifunction valve. The operator is not able to drive the machine through the parking brake due to the neutral override spool, item 16. This is because the path to tank is open for charge pressure. Once the parking brake solenoid has been active, charge pressure is applied to the other side of the neutral override spool, shifting it, blocking off the path to the tank and allowing pressure to build to stroke the pump. PS1 and PS2 are pressure switches that must agree with their readings if the park brake solenoid is activated. If these two pressure sensors do not agree, a fault code will be shown on the AIC. The brake cylinders are located at the final drive box. Charge pressure leaves the multifunction valve at ports U1 and U2 and goes to drive motors. Hey Gary, take me to the drive motors.
Finding directions to the drive motors. Directions found. Would you like me to take you there?
Yes.
Okay.
Charge pump pressure enters port U on the drive motors. Charge pressure here is used only for cooling and lube. Oil returns to the multifunction valve and then is diverted to the cooler to be cooled and then returns to tank. The hydrostatic motors are directly mounted to the final drives. They are much like a piston pump internally, but they cannot be destroked to zero because they are a bent axis motor. The swash plate stop bolts are set by the factory. However, They may require adjustment in the event of missed tracking. The speed sensor, item 2, reports to the UCM how fast each motor is traveling. The UCM takes the reading of the right-hand drive speed sensor and adjusts the pump and motor of the left-hand side to match the same speed. This is the straight tracking logic used by the UCM. The flushing valve, item 6 in the schematic, allows for cooling of the loops. You'll notice that oil is drawn out of the low pressure side of the loop and sent back to the tank. Remember though, we do have makeup oil that's added back into the loop at the pumps to help maintain the right amount of oil in the loop. This concludes our hydrostatic schematic tour of the 750 and 850M, as the hydrostat and hydraulic system reservoirs are the same. Thank you for taking the tour with us today.